So we like Python functions. We've seen if you know the formula, you can easily put it in. If you have the idea of it, then there's a way to start on that too. So let's make another function called numerical range. And numerical range is going to take a set. Notice how I'm having to describe all of these in some way. I can't just start typing them. Takes a set and calculates the difference between the largest element and the smallest element. Does that make sense?
So, for example, if you had a list that was 1, 2, and 5, it would return 4 because it would look at the difference between 1 and 5.
Yes, exactly. Another way we could say this Another way we could say this in words is this is the maximum of x minus the minimum of x. I like that example you just constructed. So we can write this function. Let's try to do that because I'm going to appeal to functions that already exist.
That's the best way to do it. If there's a function that will do the thing you are trying to do, why reinvent?
I mean, there's one good reason to reinvent the wheel, which is to understand how wheels work.
Right.
But if you're just trying to get somewhere, don't waste my time and money by doing things that have already been done.
And I cannot reiterate enough how important that idea is in computer science as a whole, of the concept of abstracting things away. I mean, when you're writing functions, that's part of it, right? You are abstracting logic in a way that makes things simpler. You are taking bits of logic and turning them into something that can be easily callable, easily used by other people, without them having to understand exactly how you wrote that function and how it works. And this becomes more important the deeper you get into computer science. I mean, this becomes like most of what you do. You can think of something like sklearn, for example. That's all big abstraction. You don't have to know how each of those functions is implemented, how each of them is written. You just have to know how to use them, and that enables you to make more progress as opposed to you having to write, linear regression by yourself or k-nearest neighbors by yourself.
You have to write linear regression by so I was once very proud as a math student, and I didn't want to use any results that were known. I wanted to discover everything for myself. And I realized I was going to get to about 1800 by the end of my career. You have to be able to things even that you don't 100% understand completely. And it's the same thing with theorems. Like you can think of theorems like an API. Like, oh, I may not understand the proof of this theorem, but I can use this theorem to get what I want. So we're going to try to write this numerical range function, and I'm going to write my description here. This function takes a set of integers and returns difference between the largest number and the smallest number in the set. So ram x is a set of integers. Return is the difference between the largest and smallest. Now we're going to look at some examples. So I have a numerical range of 1, 2, 3, 4 should be 3, and a numerical range of 0, 2, 4, 6, 10 should be 10. Now, let's see what can we do here.
Well,
any thoughts on how we could write this?
I think the way I would start out this is we know that there are at least two parts to this. We need to figure out what our minimum value is, and we need to figure out what our maximum value. Then we need to subtract and find the difference between these two numbers. And it's one thing that's important to keep in mind is that for each of these steps, we could write our own function that do each of these steps. We could write a function that found a minimum. We could write a function that found the maximum value in a sequence. But like we said earlier, we're going to use abstraction. And we know that these are existing functions already that somebody else has written. So I say it's a good place to start by using those.
All right.
And always a good place to start with documentation if you don't know if something exists or not.
So you get a maximum of a set in Python.
Geeks for Geeks is a pretty good website.
Now, what I do not like here at all is I don't like the fact that this is a print.
Yes.
I don't like that at all. Okay, the built-in max function in Python is used to get the maximum of all the elements in the set.
So that's at least, that gives us one side of the coin.
Okay, so I bet that there's a function min also.
In fact, I believe that article was also talking about that.
So I'm going to figure out the minimum and the maximum, and I'm going to say range x equals max x minus min x, and then return range x.
Now, just to be clear about something,
yeah.
I'm noticing that you have your range x there. You're reusing the max and min functions when you've assigned them the variable.
Oh, that's a terrible idea. Yeah, that's one of the worst mistakes people make is they'll do like 4x and x, y equals np.max x or something like that. You never want to calculate inside a loop, and you never want to recalculate what's already been assigned.
Yeah, preferably the less work. Sometimes it's unavoidable, but preferably you can avoid doing work in a loop. Don't do it. And if
Cool.
you can avoid redoing work, don't do that.
I'm going to check my set here. It gives the answer I expect on the set 1, 2, 3, 4, and then on the set 0, 2, 4, 6, 10. Gives 10, so it's checking out with what I expected. But you're absolutely right. It's really much better to look things up for things like this that may be already known. Now, it's some of these things, it's important that you understand it. Like, there's a reason it's worth getting in the weeds sometimes on the documentation or on a proof, and that's so you understand the idea.
Absolutely.
So you can find a program that will calculate the nth Fibonacci number for you. But when there's a job interview question that uses the concept of recursion or memoization, you'll be stuck if that's all you've ever done.
That is absolutely true. I mean, it is important, like we talked about, to abstract away things and to not have to know how everything works. But sometimes you do. Sometimes you do have to know how things work, and that's where the documentation absolutely comes important. That is very true for things like sklearn. That is very true for libraries like stats models. I mean, how else would you know, for example, how they are implementing what algorithm they're using for linear regressions? How would you know what parameters to pass into their functions to give you to give you the things that you need, as opposed to just giving you random stuff that you have no use for? Or how would you know how to access certain property of the objects of those functions? That's all through the documentation. And so,
Well,
while abstraction is important, it is still important sometimes to be able to cut through the weeds, like you were saying.
I want to do something where we don't have a formula or a built-in function, because that is important as well. That is really important to be able to know that a function isn't always a formula. If you have especially with finite sets, you can make whatever you want be a function. Like, sometimes this is really practical. If you're mapping, you could have a function that takes a VIN number of a North Carolina car and returns the license plate number. I don't think there's any rule for that other than this is the VIN number, this is the license plate number. You see what I'm saying?
Hmm.
So there, you can define a function via a table or a database, or just saying this goes to this. There doesn't have to be a formula for it. And how could we do that in Python? For myself, I think this is where I would use a dictionary. Let's say we had a function that looked like, so it's just z, and you have 1 goes to 4, 2 goes to 3, 3 goes to 1. Now you might be able to come up with a formula for this, but it's not important to do so, right? There are two ways you can do this. One is you could define z, and you could say if x equal 1, return 4, if x equal 2, return 3, if x equal 3, return 1, else return none, because it's not defined for anything besides 1, 2, and 3. So that works, right?
Certainly does work.
But it wouldn't work for something like the 9-2 number function. So every student gets a 9-2 number. That's a function. And I don't want to have I don't want to have 10,000 different cases, one for each student. So my proposal is to do this as a dictionary. Does that make sense to you?
Yeah, yeah, absolutely. Yeah, dictionaries are very important and quite similar to objects in some sense. So yes, I think that's perfectly valid.
So I would say Z is, so the way the syntax works is the input first, colon, then the output. So 1:4, 2:3, and 3:1. And there's some people think that you have strings. You don't. You can make your keys and values be anything.
Right. I mean, if you really want to think about lists, for example, a list has indexes which are numbers. So no problem with using numbers. And it's important with a dictionary to recall, to emphasize that what you're doing is you're creating key value pairs. So your keys are what allow you to access the value at that specific key. So in your case, you have the keys 1, 2, and 3, and then the values 4, 3, and 1.
And actually,
One is
the keys are the domain.
yes.
The keys in a dictionary correspond exactly to a domain in mathematics. I've created this thing. Now, how do I call it? How do I evaluate z of 1?
I think you can do just z bracket 1, just like you would with a list, because again, just like we talked about before, a list has integer keys just like what we have here. And so it's really no different from what you would do with a list, trying to access the value at a specific index.
This is a pretty good overview of the big ideas of Python, of functions in Python, and how those connect to big ideas of functions in mathematics. Because really, they should be the same thing. I think of functions in Python as sort of like a practical approximation of functions in mathematics, but like, there are lots of times where I've needed to write functions in Python to help me with my math research.
Oh, absolutely, yes. As the same boat here.
So I'm wondering if you have any other things, as someone who's done a lot of both, do you have any other comments on how math and computer science help each other or work together, or any differences between them?
Oh, math and computer science, they go together like this. They have so much overlap between the two of them that it's almost not even funny. It's in fact it's pretty amazing because the mathematical side of things, even if you are a pure computer science, all you do is you're always working with math at the end of the day. You really can't escape it. If you happen to have the ability though, to understand math, you can abstract away a lot of. I want to be clear about that. You can abstract away a lot of math. That's not always the best idea, but it is certainly something you can do. If you have the ability, though, to understand math and understand computer science, you will. I think you will find that you have the ability to do a lot of really interesting things and to tackle a lot of really interesting problems.
Well, Justin, thank you so much for talking with me and sharing what you know, and I look forward to talking to you again soon.
Yeah, thank you.
Take care.